So my dear student, next I'll go to the next reaction, that is double displacement reactions. There is an activity here in a book, that is 1.10 activity, that is take about 3 ml of sodium sulfate. The symbol for sodium sulfate is Na2SO4. Sodium has the valency of 1 and SO4 has the valency 2. That is why this symbol is Na2SO4. Next, in another test tube, take about 3 ml of barium chloride solution. So symbol for barium chloride is BaCl2. So barium has the valency 2 and chlorine has the valency 1. So we get BaCl2. Next, mix the two solutions. Both solutions are mixed in this test tube. You see here, this is containing solution of sodium sulfate, which is for in the another test tube, that is test tube containing solution of barium chloride. Then what will happen? So what will happen? The sodium sulfate and barium chloride will react each other, but there is one condition. Condition is that you will observe that a white substance which is insoluble in water is formed. So there will be a product which is insoluble in water. So insoluble means which is not soluble in water, which will act as a precipitate. Okay, so this insoluble substance is formed known as precipitate. This insoluble substance is known as precipitates. Any reaction that produces a precipitate produces a precipitate can be called a precipitation reaction. This is called precipitation reaction. So in a chemical reaction, if one product is precipitate, then the chemical reaction is known as precipitation reaction. This is also known as double displacement reactions. So what's happened in the double displacement? So there is a process by which the double displacement occur. You see, this is double displacement reaction. Here sodium sulfate plus barium chloride, it will form NaCl, that is sodium chloride plus barium sulfate. So what will happen? First of all, the sodium atom will get ionized. So what will be the numbers of ions? That is, this is positive 1 because sodium has the valency 1. So how much valency of an element it will carry? Such charge. So this is 1 valency, that is it will carry 1 charge. Okay, so SO4 has the valency 2, but it is one of a non-metal group. That is why it is written as minus. So this is plus, this is minus. Both the plus and minus ion will form a salt, okay, in the forming ionic bond. Next, this is barium and this is chlorine. So barium is the valency 2, it is a metal, so it is written as Ba2 plus, and the chlorine is the valency 1, so it is called Cl1 in as an ion, and as the numbers of chlorine atom is 2, so we should write here 2. Okay, so what will happen? Then the positive of this compound will meet the negative parts of this another compounds, and thus the ion is exchange. Okay, so ions plus will meet negative, and the positive will meet with the negative of the another compounds, and forming a compound NaCl and barium sulfate. So the barium sulfate from this compound product, what will happen? One product will precipitate. So why barium sulfate is precipitate? So there is also a rule of solubility. So what will happen? The soluble substance will not precipitate from the solution, but the insoluble substances will precipitate. So there are the questions that what substances will be soluble in water and what will not be soluble. So for that you have to memorize some points, some lines, some compounds which are soluble and which are insoluble. So which one would be insoluble? Will be precipitate in the solutions. So let me tell you what substances will be soluble and what substances will be insoluble in water. Okay, so let's see. All alkali metals compounds are soluble. So alkali metals means, so you will see a periodic table, the first group metals are called alkali metals. Okay, so I like to see the please turn to the 86 page. Okay, in the 86 page you will get the periodic table. Okay, this is called alkali metals and this is called alkali earth metals. So these alkali metals, about the alkali metals and about the alkali earth metal, I will tell you in the next class, that is in this continuous class. So just remind what is alkali metals and what is alkali earth metals. This is alkali metals and this is alkali earth metals. Okay, so let's go to the equations. So what will happen? The all alkali metal compounds are soluble. All ammonium salts compounds are soluble, like ammonium chloride, ammonium hydroxide. Okay, this is first rule and this is second rule. All alkali metals compounds are soluble. So alkali metals means the elements which is found in the first group, that is lithium, potassium, sodium, then others. So all these alkali metals compounds will be soluble in the solution of water. That is why it will not precipitate. Okay, next, all ammonium salts, that is compounds, are soluble, like ammonium chloride. If in the product we see there is ammonium chloride, there is ammonium hydroxide, then this will not what is called precipitate. Okay, next, all nitrates, chloride, perchlorate, acetate salts are soluble. All nitrates, symbol for nitrate is NO3, sodium nitrate, potassium nitrate, etc. So all nitrates salts are soluble. Next, all chlorate, Cl4 chlorate, so chlorates are also soluble. Perchlorates are also soluble. Next, acetates are also soluble. So this type of salts are soluble in water. If there is potassium nitrate or potassium chlorate, potassium perchlorate, acetate, etc. So this type of salts where nitrates, chlorates, perchlorates, acetates are found, these salts are soluble in water. That is, these salts will not precipitate from the products. Okay, next, all chloride means Cl, bromide, Br, and iodide salts are soluble, except silver, that is silver chloride, silver bromide, or silver iodide will not be soluble in water, it will precipitate. Okay, next, mercury. So mercury chloride, mercury bromide, and mercury iodide will be insoluble, that is it will precipitate. Next, lead. Okay, lead 2 plus, lead has a valence of 1 and 2. So lead chloride, lead bromide, and lead iodide salt will be insoluble in water. As a result, it will precipitate. But the other chloride, bromide, and iodide soil are soluble, that is other chloride, bromide, and iodide soil will not precipitate from its solutions. Okay, next, all sulfate compounds are soluble except barium, strontium, calcium, lead, and mercury. So all sulfate means SO4. Okay, all sulfate compounds are soluble, but what's happened? except barium, that is barium sulfate, strontium sulfate, calcium sulfate, lead sulfate, mercury sulfate. If the product is barium sulfate, strontium sulfate, calcium sulfate, lead sulfate or mercury sulfate, then it will be insoluble in water. As a result, it will precipitate. Okay. Next, all hydroxide compounds are insoluble except calcium hydroxide, strontium hydroxide, alkaline metals. I have told you about the alkaline metal, that is the element of first group of periodic table. That is, all hydroxide compounds are insoluble. Insoluble, that is, it will precipitate except calcium hydroxide. If the product is calcium hydroxide, one of the product is calcium hydroxide, one of the product is strontium hydroxide, and one of the product is from alkaline metal hydroxide, then it will be soluble, that is, it will not precipitate. Okay. So next, all sulfide compounds are insoluble. Sulfide compounds, sulfide means Na2S, whenever this is S, this is called sulfide, not sulfate, sulfide, except alkaline metal and earth metal. So all sulfide compounds are insoluble, that is, it will precipitate if it is one of the compounds. If it is one of the compounds of the products, then what's happen, it will precipitate. But if the sulfide compound is of from alkaline metal and alkaline earth metal, that is the elements which is found in the first group and the second group. I have already told you that the first the element which is found in the periodic table in the first group, it is called alkaline metals, and the element which is found in the second group of periodic table, it is called alkaline earth metals. So the alkaline metals and alkaline earth metals sulfide compounds will be soluble, but other sulfide compounds will be insoluble, that is, it will precipitate from the solution. Okay. So next, all sulfides, sulfide means SO3, not sulfate. Okay, it is sulfide, that is SO3. So sulfide means S, sulfate means SO4, and sulfite means SO3. Sulfide, sulfate, and sulfite. Okay, it is sulfide DIDE, sulfate ATE, sulfide ITE. Okay. So all sulfide carbonates, carbonates means CuT, chromates and phosphates are insoluble. Chromates, we have already found potassium chromates. So chromates, phosphates, sulfides, carbonates, all these compounds are insoluble, that is, it will precipitate. If there is a product which is sulfides, carbonates, chromates or phosphates are insoluble, it will insoluble, that is, it will sit at the bottom of the test tube, except ammonium and alkaline metals. Alkaline means the elements of the first group of periodic table. So the ammonium, if it is ammonium sulfide, ammonium carbonates, ammonium chromates, and ammonium phosphate, then it will be soluble. Okay, it will not precipitate. So if it is sulfides of alkaline metals, that is the elements of the first group forming sulfides, carbonates, chromates, phosphate, then what will happen, it will be soluble, that is, it will not precipitate from the solution. So this is all about the precipitation, that is the elements, that is the compounds which will precipitate from its product will be identified by these rules. So I hope you will understand and memorize these rules, because it is very important to know which product will be precipitated from its solutions. So this is called double displacement reactions. Next, see at your book, what causes this just precipitate. The white precipitate of barium sulfate is formed by the reaction of SO4 2 minus and Ba2 plus. Okay, so SO4 2 minus and Ba2 plus, this is positively charged ion and this is negatively charged polyatomic ions. So this will form barium sulfate. The other products form is sodium chloride, which remains in the solution. Such reaction in which there is an exchange of ions between the reactants are called double displacement reaction. This is called double displacement reactions. So what's happened? The reaction in which there is an exchange of ions between the reactants are called double displacement reactions. Exchange of ions will take place between the reactants, not within the products. So whenever the exchange of ions take place within the reactants, it will form products, and from the products, the products which will be insoluble in the solutions of water, it will set at the bottom, that is, it will precipitate. That is why it is double displacement reaction is also called as precipitation reactions. So there may be one question, that is why you should write the question as well as write the answer also. Why does the double displacement reaction also known as precipitation reaction? Okay, so there is another possible question, that is give the difference between double displacement reaction and displacement reactions. I hope you can write these question answers. Next, recall activity 1.2. So there is a reaction which we have studied in the activity 1.2. So I hope you remember it, in which what's been lead nitrate solutions, lead to nitrate. Okay, that is the lead has the valence 2, lead to nitrate. That is the symbol for the lead nitrate will be PbNO3 all bracket 2. Okay, which reacts with potassium iodide. This is potassium iodide. What was the color of the precipitate form? So this will be a double displacement reaction in which one of the product will precipitate. So can you name the compound precipitate? So you are asked to name the precipitate, the compound which is precipitate. So I have already told you about the product which will precipitate, that is which will be insoluble. So insoluble products will precipitate. You see there is a question, okay, so in which you are asked about the precipitation, okay, the precipitate substance. So if you do not know about the insoluble and soluble products, then how can you be able to tell about the precipitation or precipitate substance? So you should just memorize the insoluble and soluble substance and the exceptions also to get the answers whenever such type of question is asked, that what products will precipitate. Then you will automatically know the products which will precipitate from its products. Okay, so write the balanced chemical equation for these reactions. And is this a double displacement reaction also? Okay, it is a double displacement reactions. So you see how this reaction occurs. Here, this is lead to nitrate, that is the valency of lead is 2, that is why NO3 has valency 1, that is why PbNO3 whole bracket 2. Okay, so next, potassium iodide. So it will form ion first. Lead has the valency 2, that is why Pb2 plus, it will be positively charged. NO3 has the valency 1, there is 2 groups, that is why there is 2, and the valency 1, that is why I write the charge as negative. It is positive, it is negative. By the positive and negative, these ionic compounds are formed, which is also known as salt. Okay, next, potassium iodide. Potassium is the valency 1, that is why the charge is plus 1, and the iodine has the valency 1, that is it will carry minus 1 charge. Okay, so after exchanging the ions, it will form product lead iodide, that is lead will meet the iodine, lead iodide, that is the lead has the valency 2, iodine has the 1, that is why lead iodide, and potassium nitrate. Okay, potassium has the valency 1, also nitrate has the valency 1. You should balance this equation. I am not balancing it. So you see lead iodide will precipitate. Okay, lead iodide will precipitate. Potassium nitrate will remain soluble in the solutions. So we have already studied about the lead lead salt solubility. Okay, so you see this is the all sulfate compounds are soluble except barium, strontium, calcium, lead, etc. Again, all hydroxide insoluble, all sulfide compounds are insoluble. Next, all sulfide carbonates are insoluble. Next, this is so if you remember it, if you memorize it, then you will automatically know what salt will be, what salt will be, or what products will be insoluble or soluble. You see these lines: all chloride, bromide, and iodide salts are soluble. All are soluble: chloride, bromide, and iodide. This is iodide salt, except silver, mercury, and lead. Okay, you see all chloride, bromide, and iodide salts are soluble except silver, mercury, and lead. So you see in this reaction what's happened? In this reaction what's happened? Lead iodide. Okay, lead iodide was exception. Okay, that is, it is insoluble, that is why it will precipitate. So to know what products will precipitate, you should know these rules. Okay, so just memorize these rules, then you will be able to tell about the precipitations. Okay, so thanks for today. I'll test you in the next class if it is possible for me, and give allowed time to ask some questions, but due to the shortage of times, I do not be able to ask some questions. So prepare yourselves, so don't let any rules, any questions, and any things to memorize. So just write the question and answers and memorize it, then you will be benefited. You see in your textbooks there is not any indications of solubility or insolubility, that is soluble or insoluble substance, but the question is asked, that is in these questions you see you are asked what are the color of the precipitate, can you name the compound precipitate. So if you know these types of questions and this type of answers, so you should know some extra knowledges. Okay, so you should know the solubility rules, that is which one will be soluble or which one will be insoluble. If you can memorize it, then you can automatically answer this type of question. Okay, so thanks for today, have a nice day.